students. So we are discussing motion, right? Okay, so in that part, in last class also we discussed about problems, right? So let us continue the same motion lesson problems part. Let us discuss different types of problems, where we should apply which formula, how to solve the problems. Okay, so see, an athlete, first problem, an athlete completes one round of a circular track of diameter 200 meters in 40 seconds. He is completing one round around a circular track. Okay, see, an athlete completing one round, okay, around a circular track in 40 seconds. Okay, so suppose consider a circular track of diameter 200 means radius 100. Okay, so he is starting at this point. So t is equal to 0 starting point. Let us divide this into 4 parts so that you can understand clearly. Okay, so here diameter is equal to 200 meters. So diameter is equal to 200 and nothing but radius is equal to d by 2. So d is nothing but diameter 200 by 2, that is equal to 100 meters. That is radius. Okay, here what will be the distance covered and the displacement at the end of 2 minutes and 20 seconds. Okay, after 2 minutes and 20 seconds, how much distance he covered and what is the displacement. Okay, so distance is nothing but total path of total length of the path distance, and displacement is shortest distance between final and initial position. Okay, so to complete one round, how much time he needed? 40 seconds for first round. Okay, 40 seconds for first round. So for 2 rounds, how much time he will take? 80 seconds for 2 rounds, right? 2 rounds. And for 3 rounds, 120 seconds. Okay, for 3 rounds. Here how much time, what he is asking in a distance and displacement. In time 2 minutes 20 seconds, that is equal to 140 seconds. Okay, so here 140 means for 3 rounds 120. How much extra time he is traveling? 20 seconds extra. In 20 seconds he can complete half circle, right? Yes or no? In 140 seconds he is completing 3.5, means 3 full rounds and off. Okay, here is the final point. Okay, final point, initial point here starting and final point here. Okay, so in 3.5 round, so in one round how much distance he is covering? Perimeter of a circle, right? Yes or no? Circumference of circle. Perimeter is nothing but, in case of a circle we consider that is a perimeter, I mean circumference. Okay, distance in one round 2 pi r. Okay, in 3.5 rounds we have to multiply this perimeter or circumference by 3.5. Okay, so distance covered in 3.5 rounds is equal to 3.5 into 2 pi r. Okay, so that is equal to 3.5 into 2 into pi value 22 by 7 into radius how much? 100. Okay, here 7 ones are 7 5s are. See, multiply how much you will get? 2200 meters. Okay, this is the distance covered. Okay, so what is the displacement? Displacement is nothing but shortest distance, right? So shortest distance between initial and final position is how much? Diameter. Okay, that is equal to diameter. How much is diameter? 200 meters. Okay, so displacement is equal to 200 meters. Okay, so this is a problem. Understood? So let us move to the second problem. Joseph jogs from one end of A to the other end B of a straight line 300 meters road in 2 minutes 30 seconds. Okay, so he jogging in a straight line from A to B of 300 meters road in 2 minutes and 30 seconds, and then he turns around and jogs 100 meters back. After reaching B, he is jogging back to point C, that is 100 meters in 1 minute. So what are the Joseph average speed and average velocities? A to B and A to C. Okay, so let us, for each and every problem, try to draw a rough diagram, then after try to solve. Okay, so what he is asking and what parameters he given. See, so first he's jogging from A to B, that is 300 meters in 2 minutes 30 seconds, means it's nothing but if you change totally into seconds, that is 150 seconds. Okay, so average speed from A to B is equal to total average speed formula. What is that? Total distance by total time. Total time. So here what is the distance? 300 meters by 150 seconds. So that is equal to 2 meter per second. Okay, it's 2 meter per second. So if the body is traveling in a straight line, average speed and average velocity both are same. So here the same thing, 300 meters by 150 seconds. The just formula is different. Displacement. Okay, so here total displacement by total time, that is equal to 2 meter per second. This is average velocity from A to B. Okay, so next average. So he is asking average speed and velocities from A to B and A to C. So A to B, that is average speed and average velocity. Both are same because he is jogging in a straight line path. If he jogs like this in a curved path, we have to measure the total distance. Here varies. Okay, displacement is same. If he is jogging in a circular, like a curved path, or if he is taking any diversions, then in that case we have to add a total length of the path, then we'll get a distance. Okay, so next average speed from A to C. A to C. So average speed from A to C, again total distance by total time. So A to C, he covered two distances, right? First 300, then after 100. Okay, so 300 meters plus 100 meters by total time. First he took 150 seconds, then after 60 seconds. Okay, so that is equal to how much you will get? 400 meters by 210 seconds. Okay, so here 0 cancel. If you do calculation, you will get 1.90 meter per second. Okay, now this is the average speed from A to C. Okay, next average velocity from A to C. Total average velocity formula, total displacement by total time. Okay, so total displacement is how much here? Just 200 See A to C straight line path. How much here? Though this from A to B, that is 300. Here B to C 100. If you subtract, then you will get a 200 meters by time same 150 seconds plus 60 seconds. That is equal to 200 meters by 210 seconds. 0 cancel. If you solve this, you will get 0.95 meter per second. Okay, so here direction, if you mention he's traveling, Joseph jogging in south or north, if he mentions direction, then you have to compulsory mention direction for average velocity in both the cases. Okay, here he not mentioned the direction, that's why I'm leaving like this. Just mention like this, direction from A to C, and here a direction from A to B, A to B, like this, just mention. Okay, this is understood. Next, third problem. Abdul, while driving to school, computes the average speed for his trip to be 20 kilometers per hour. On his return trip along the same route, there is traffic is less and the average speed is 30 kilometers per hour. So what is the average speed for Abdul trip? Okay, while going he's maintaining the average speed of 20 kilometers per hour, and while coming back he is maintaining 30 kilometers per hour due to the less traffic. Okay, here in this case we have to find the overall average speed for his trip. Okay, see, for each and every problem try to draw a rough diagram. Okay, so he is traveling from, let us consider A is his home and B is his school. So distance is x kilometers, let us consider. Okay, so while going, or speed, say speed while going from his home to school, that is I'm taking as v1, it's equal to 20 kilometers per hour. While coming back, v2, that is equal to 30 kilometers per hour. Okay, so distance I'm taking x. Okay, so here we have to find speed of A to A, nothing but so speed while going and coming back, and initial and final position is A. So in this case displacement is 0. See, we know average speed formula is equal to total distance by total time. Here we don't know time, we have to find the time. Okay, so TAB, speed is equal to distance by time. So from this formula, time is equal to distance by speed, right? Okay, TAB is equal to distance by speed. Distance we already assumed to be x, right? X by v1. Okay, so TBA is equal to the same x by v2. Okay, so now apply average speed formula. Average speed is equal to, see, total distance in his journey he is traveling while going x and while coming x by total time x by v1 plus x by v2. Okay, so 2x by x by v1 plus, see, 2x, x plus x is equal to 2x by x by v1 plus x by v2, that is equal to 2x by, I'm taking x common, so 1 by v1 plus 1 by v2, x cancel. So what is left here? 2. If you take LCM, 2 by v1 plus v2 by v1 into v2, that is equal to 2v1 into v2 by v1 plus v2. Okay, if he asks while going and while coming, he'll mention different values of average speed, and he'll ask total average velocity in his journey. We can use direct formula this. Okay, so now substitute the values given. 20 into 30 by 20 plus 30 is equal to 50. Okay, so try to solve here. 5 4s. So how much you will get? 8 kilometers per r is a average speed. Okay, like this we have to solve. Okay, so next problem. See, a motorboat starting from rest on a lake accelerates in a straight line at a constant rate, that is 3 meters per second square, for 8 seconds. How far does the boat travel during the see how far does the boat travel during this time? Okay, so what is parameters he given? This boat is starting from rest, right? So initial velocity is equal to 0. So what is the acceleration? 3 meter per second square. How much time it is taking to accelerate to 3 meter per second square? It is 8 seconds. Okay, we have to find here distance. Okay, distance. So what are the three formulas? Okay, v is equal to u plus at. We have these formulas, right? S is equal to ut plus of at square, and v square minus u square is equal to 2as. See, while selecting the equation, I already said observe the parameters, what he given and what we have to find. So here we have to find a distance. So the formulas including distance are these last two formulas. Okay, so again in the last two formulas, he is not given v, right? Final velocity not given, so we have to use a second one. Okay, so s is equal to ut plus of at square. U is nothing but here 0, 0 into t plus of into a, nothing but 3 meter per second square into time 8 second into 8 second, second square cancel, and this 4. Okay, so here 0 plus 3 into 4 into 4 into 8. Okay, meter per meters, sorry, seconds already cancelled, right? Meters. So how much you will get? 12, 3 4s are 12, 12 8s are 96 meters. Distance is equal to 96 meters. Like this we have to find distance, 96 meters. So like this we have to select the equation depending on the parameters given to us and what he is asking us to find. Okay, so clear, right? So he given, see, mentioned boat starting from the rest. Starting from the rest is nothing but we have to take a initial velocity 0, and it is accelerating to 3 meter per second square in 18 seconds. So like this we have to select the equation, we have to find the given, what he is asking for us. Okay, so next let us see the last problem in this lecture. Okay, see, a driver of a car traveling at a 52 kilometers per hour applies the brake and accelerates uniformly in the opposite direction. Okay, if you apply the brakes, what happens? After some time it comes to rest. So the car stops in 5 seconds. Another car driver going at a 3 kilometers per hour in another car applies the brake slowly and stops in 10 seconds. Okay, so on the same graph paper, see, so let us consider case 1 and case 2. In case 1, so already he is traveling with the speed 52 kilometers per hour, means initial speed is equal to 52 kilometers per hour and acceleration is constant. Okay, and here in the second case initial velocity is equal to 3 kilometers per hour, acceleration is constant, and if you apply gears or brakes, that final velocity is 0, means after some time it comes to rest. So what time he's taking to come rest? It's here 5 seconds and here 10 seconds. Okay, so what he's asking on the same graph paper, plot the speed versus time graph for two cars and which of the two cars traveling further after the brakes were applied. Okay, so after the brakes applied, which car is moving more distance before coming to the rest, that we have to plot on the graph. Okay, so we have to plot the speed and time graph. So when acceleration is constant, then speed and time graph will appears to be straight line, means it will, if you draw even while taking the values also, you will get a straight line. Okay, so these are the case 1 and case 2. After applying the brakes, it is coming to rest after 5 seconds. This car is coming after 10 seconds. Okay, which the car moved far distance after applying the brakes, that we have to find. Okay, so here time is 10 seconds and 5 seconds. You can take a 5, 10 like that, scaling on the time graph, that is on a x-axis and y-axis. Here it is, we have to get a 52, 3, 6 and 9 like that. We can take up to 52. Okay, so time and speed graph is straight line, right? So 52 to 5 seconds, I'm drawing a straight line. Again 3 to 10 seconds, again one straight line. So we have to find this area and this area. Okay, and we have to decide which one is more value, that becomes our answer. Means so the area enclosed by the speed time graph and time axis is equal to the magnitude of the distance covered. Okay, so what is here? The area. See what is area, how to find if the graph is given or by with the help of graph. The area enclosed by speed time graph on the time axis is distance covered. If he mentions or if he give the speed time graph also, we can find the area of these graph enclosed. Okay, so here what is this? This is appears to be a right angle triangle, right? This is also one right angle triangle. Try to find these right angle triangle areas and apply compare the values, which first I'm finding in a case 1. Okay, see in first case, distance is equal to area of a triangle ABD. Okay, so let us consider ABC and D is the points. So in first case, the distance covered is equal to area of triangle ABD. So triangle area formula of into base into height. Base is how much? Of into 5 into height 52, and we have to get a distance in meters. That's why I'm converting. That is to convert kilometers per hour into meter per second, we have to multiply with the 5 by 18. Okay, so try to do the calculation, how much you will get here. Here you will get a distance is equal to 36.11 meters. Okay, try to do this calculation. Okay, so in case of second case, distance is equal to area of a triangle ACE. Okay, so ACE. So that is equal to half into again base into height. Half into base how much here? 10, and height how much? 3 into 5 by 18. Okay, so 3 6 and 25 by 6 meters. That is equal to how much you will get? 4.16 meters. Okay, so in which case we score traveled more distance? In case of first one. Okay, so in this case, first case, the car traveled more distance. Like this we solve the problems. Okay, so homework timing slot is not fixed. Okay, so try to check the homework up to 3:30 from 1 o'clock. Okay, so try to do the homework. This chapter is very important for your further classes like 10th and inter even. Okay, so try to listen the class. If you have any doubt, revise the video or go back to the which problem you not understood, that problem, and try to solve. Today's homework you consist only problems. Okay, units are very important in a physical terms. Okay, thank you.